Let's see. Okay.
Test.
So it seems like we're on, so that means that we have to start. The room monitor has got a very watchful eye because she knows happy hour starts right after this, and so we're going to be very timely, pünktlich as they say in Germany, and try to stay on time. My name's Steve Crum. I'm the Executive Director of GENIVI, and I'm probably the only person at this conference that knows very little about big data. That's not my job, and so you're not going to learn anything about big data from me. I'm here as an alliance guy, and I'm the Executive Director of the GENIVI-Alliance, which we'll introduce in a little bit. And I'm also a little bit more of a city guy in the sense that I've done some projects with various cities, connected vehicle projects. And that's what we're going to talk about today, is this interesting marriage between connected cars and cities, and what sort of things cities can learn once the data starts flowing from cars. If you were in the Ford presentation earlier, this is not that presentation at all. Okay, those guys have a budget, and they have the ability to control everything. And our situation is we're a volunteer-driven open alliance, and so I can't control anything. And so you're going to see quite a difference between that presentation and this one, but I think it's going to be an interesting one either way. So this is the agenda. I won't spend a lot of time on it, but I just want to introduce you to the pilot project that we've started with Las Vegas and sort of the use cases. And Marcus, who knows a lot about big data and a lot about Hadoop and works for Hortonworks, is going to answer all the hard questions that you might have about how this thing is working. We'll do an application walkthrough, and we'll end up with a benefit slide to why in the world would Las Vegas want to do something like this. So with that, we'll go forward. So in January, the GENIVI-Alliance, which I'll tell you about the GENIVI-Alliance in a second, signed an agreement with the Nevada Center for Advanced Mobility, or NCAM for short, and their partners, which includes the City of Las Vegas and the Nevada Department of Transportation and the Southern Nevada Regional Transportation Committee, UNLV, and a number of other partners. We signed this agreement to do this one-year pilot. And from the city's perspective, their goals were twofold. They wanted to increase awareness of pedestrian safety, and they also wanted to assist in traffic flow in Las Vegas. Why would Las Vegas care about those two things? Well, on the first one, on the pedestrian safety, Las Vegas unfortunately has the distinction of being having the second highest pedestrian fatality rate of any metropolitan city in the United States. Probably has something to do with the amount of alcohol consumed in the city and nothing to do with the roads, but they've got to do their job, and we are hoping to help them do that. On the assist traffic flow in Las Vegas also does something interesting. The way to think about Las Vegas is that every weekend they have the equivalent of a Super Bowl. So, you know, when the Super Bowl hits Phoenix or the Super Bowl hits Baltimore, or well, maybe not Baltimore, but Miami, you know, it's a once-in-a-year activity, but with Las Vegas, they have so many visitors hit every weekend. It's like hitting a Super Bowl traffic weekend every weekend. So they have a significant challenge with traffic flow. And so GENIVI is this open, connected car community. We produce software, open software for in-vehicle infotainment systems. That's that little box in the middle of your car dashboard that tells you where to go and when to pick up Bluetooth phones and things like that. We're roughly about 145 members all over the world. We have about 13 different OEMs or automakers. And we are not a commercial product deployment organization, but the software that's been written in the context of GENIVI is now deployed in roughly 25 products worldwide. So if you have a BMW 3 or 5 series or a Mini that you've bought in the last 3 years, it probably has GENIVI software running the infotainment system in the middle there. So that's an example of what we produce. About December of 2015, we decided to expand our scope from just in-vehicle infotainment to include connected vehicle activities. And Jaguar Land Rover, one of our members in particular, was very keen to develop an open standard for communication between the car and other things, such as smart homes, such as other vehicles, such as servers in the cloud. And that technology called remote vehicle interaction is the technology base for this pilot. And we'll get into what it does here in a little bit. So again, a global community. Hortonworks is an active member. We're very happy for them to be participating not only in the Alliance, but in this pilot in particular. So kudos to them. And so let's go forward. There's an eye chart of our 145 members or so. And it's a great organization. It's been around for about 9 years, and I've had the privilege of leading it for all 9 years. So it's an exciting activity. So why? Why Las Vegas? I mentioned already that Nevada as a state, as well as Las Vegas and the county of Clark County, all have challenges in bicycle and pedestrian fatalities. It is not decreasing, it is increasing, and they've got to turn that around. And so they have launched a number of projects to help with that, this pilot being one of them. Interestingly enough, you think about pedestrians crossing at sidewalks and at intersections, but a number of 50% or more of those fatalities occur mid-block because Las Vegas is uniquely laid out. They have very wide streets and they have very long blocks. And so if you're hopping off of a bus or if you're coming out of a store mid-block, you don't want to have to walk, a quarter of a mile just to get to an intersection to cross and walk another quarter mile back to the store that's right across the street from where you are. So what do? You jump over the barrier, you run across 6 lanes of traffic and hope you don't get hit. If you do that at night and you've got a couple in your belly already, there's a good chance you're going to get hit, right? So that's what's happening there. So there's this huge amount of work that's been going on, and that was really a driving factor on why we launched this pilot project, and we hope it benefits the city, not only the citizens, but also the visitors there. We have 4 very, very simple use cases. This is, again, back to the Ford presentation. Those guys are running at rocket speed. We're just crawling and helping the city kind of learn the value of data and the value of a connected car along the way. I won't say it's easy because this guy makes it look easy and the tooling and so forth, but it's a little bit different. So speed warning, okay, you can get that on Waze, no big deal. High risk pedestrian area warning, that's a little bit more complicated because how do you define high risk? Well, that's something that's in the city data. And so you need to begin to match where the car is to where the city says that area is a high-risk area. Bus stop warning gets a little bit more interesting because we know the static bus stops, that doesn't change that often. But we don't know when the bus is offloading, which is dynamic, which is another interesting thing where we are going to go and grab dynamic data on bus actually being at a stop. And then traffic jam warning, again, something you can get from Waze or other things, but here it's much more about really deploying traffic monitors or traffic sensors through these connected vehicles. And so those are the use cases that we're using in the activity. Key measures of success, we're looking at, does the data tell us that there's actually a change in behavior if the driver gets warned that something is coming up, whether it's a bus offloading or the individual, the driver is going a little bit too fast for the context in which it is, and so forth, as well as qualitative feedback from the drivers through interviews and surveys. These are all opt-in city employees driving city fleet vehicles, and so it shouldn't be too hard to get perspectives on whether they felt like the information they got back after the data analysis happens is useful or not. That little picture there is important because there's a lot of things happening in front of the bus, But the person we really care about in the context of this pilot is the guy driving the blue car. Because the guy driving the blue car in the back there is approaching a very important context, and we want to make sure that the driver understands and is forewarned about everything that could happen as he enters that intersection. Not only is it a pedestrian zone because of the intersection, but there's also a bus offloading that we want to make him aware of. And so that gives you a little bit of a visual of what's going on in this pilot. What's happening? Not enough from my perspective. Any of you who have worked with cities are great to work with. I love them. They are slow, and procurement cycles and decision-making and those sorts of things takes time, legal documents. So basically, we've been in this pilot now for about 5.5 months, and we've deployed one unit in one car, and we're still waiting on servers to show up, and Marcus is sitting there twiddling his hands saying, I'm ready to load the Hortonworks software and get everything going, and it'll happen almost immediately as soon as everything shows up. But basically, we're still very early in the pilot, even though we're halfway through the year, but we feel very confident we will catch up in the second half and things will get interesting very soon. So what is the actual data flow, not from a big data perspective, but from a car to city context? So we've got connected vehicles out there, a growing number of them. We hope to put about 100 to 150 in the field. They're equipped with an onboard unit that runs GENIVI's open source software. It's GENIVI development platform. And it is plugged in, this onboard unit is plugged into the OBD2 port. It's got a GPS antenna, and it's every second sending information up to a server that runs a server-side version of the GENIVI remote vehicle interaction software. As I said before, the city is hosting all of the servers, and so that relationship between the car and the server goes over the mobile network. And as I said before, it happens the speed and the location of the city, or excuse me, of the car is sent up once a second. Once it gets up to the server, the RVI server, that RVI server basically becomes a data source for the magic that happens in the Hortonworks software. The Hortonworks software sits there and takes that information, combines it with many other data sources that are available within the city, including static data such as speed limits and intersection locations. Mostly it's GIS data, but also other qualitative information about zones, geofencing locations where there's a likelihood of a high pedestrian rate and so forth. When the data is combined, there's logic, which Marcus will talk a lot more about, that says, look, if there's certain combinations that occur, then we want to send an actionable message back to the driver, okay? Such as you're 200 feet away from a bus that's offloading, and you're going 10 miles an hour over the speed limit, okay? That's a situation where we want to make the driver aware. Now, we're not being fancy. These are not embedded IVI units in these cars. These are little Raspberry Pis with a little tiny screen. And so the actionable message is really quite simple combination of a graphic that's displayed on the screen as well as a sound. And the city of Las Vegas had a very significant interest in reducing driver distraction. And so we simplified the user interface as much as we could and made those actionable messages very simple to comprehend without much distraction. So the actionable message goes back through the RVI server back to the connected vehicle, displayed on the screen, and simultaneously that data that was sent from the vehicle is stored for long-term analysis and trending and data analytics. So that's the very simple flow. We'll get into how that happens here shortly. In fact, we'll get into it right now. I'll pass it over to Marcus, and he can tell you the magic that happens on the servers.
Thanks, Steve. Hi, I'm Marcus Wainio. I'm a solutions engineer with Hortonworks, working on this pilot with the city and also GENIVI. So the idea here is we have the vehicles that are producing the data The vehicles are communicating with the GENIVI software, the RVI server component. We pick up the server component with our data in motion platform, Hortonworks data flow, and we also archive off all of the messages in our data at rest platform for future analysis. And we also make available Zeppelin as a dashboard analytical tool for kind of discovering insights in that data. So the products that we're actually using are the vehicle data is being sent to the RVI server, if we do here. From there, we're pulling that with NiFi. So each vehicle is producing a message once per second to the RVI server. We're pulling that data from the RVI server with NiFi. We'll go into the flows in a minute, but we also fork off that data into long-term storage in the Hadoop cluster for future analysis. And we're also pulling in static data sources from the city. So which segments of roads have which speed limits, as well as which segments of roads are high incident pedestrian zones that the city has identified. Those are static data sets for us. We're also pulling in real-time data from the city, which is where all of their bus locations, where the buses are, and whether they are in an active loading or unloading state at a bus stop. So if we see the flow here, this is kind of the overview. We receive the vehicle data. We fork that data to implement each one of those 3 use cases as an NiFi flow. So those are happening in parallel for every message from every vehicle once per second. And then based on the outcome of those different use cases, we display different messages in the in-vehicle system. So for us, we send a warning back to the RVI server, and the RVI server handles communication with the vehicles. So in use case 1, in the RVI data ingestion, we're pulling the data from the RVI server in the city's data center. We're forking that data by to extract the GPS information from the message, as well as which vehicle we're talking about. So we send the right warning to the right guy or girl. And then we reformat that input data from the message. We're essentially just parsing the message, and we push it down into those 3 use cases that you saw in the previous slide. And then if you see the fork off to the right here, we're pushing the data, and the very last step is a put HDFS. So we're pushing that into Hadoop. In the first use case, it's fairly simple. We're taking that location data and speed data from the vehicle. We're building a location-based query on our static data set to determine if that driver is speeding at that time, do the calculation in NiFi, and then push into the warning flow. So all of this is happening, again, per vehicle, once per second.
What's your data set for the checking whether the vehicle's speeding?
What is the data set that we're checking the vehicle speed? So the city provided us speed limit data for the different streets, and we have basically a geospatial polygon for what is within this boundary. The speed limit is X. So we're just doing a geospatial query in Solar.
Right, I got that. I just wondered where it's getting data to kind of do the comparison.
Yeah, so use case number 2 was very similar to the speed limit data, but identifying high-risk pedestrian zones. So again, we're doing a geospatial query, building that query, getting the result back, determining if we are approaching a high-risk area, and then warning the driver if appropriate. Use case 3, slightly different because we're taking that location data, we're checking against the static data of where bus stops are, because those don't change very often, with the active data of where a bus is. So we know that they're approaching a bus stop. We query, is anyone at that bus stop? Is any bus actively loading or unloading there? So that we can then calculate if there is an active bus and then display the warning to the driver. And then the last flow on here, the warn driver, essentially it's the same flow. It's the output of those 3 other flows. We determine if there's a warning and which warning type that is. We build the message to send back to the RVI server, and the driver is warned by the in-vehicle device.
Okay, got all that? So why are we doing this? And we had hoped that we could get somebody from Las Vegas here for this. We're working directly with the city planner, the city architect, as she is planning out future, making future decisions about infrastructure changes, things all the way down to where you place signage that warns drivers of an upcoming crosswalk or any number of things that they would think about at the city level. Frankly, they don't have a lot of data to make those decisions. They've gotten a lot of sort of manually given data from city staff, citizens, police reports, things that come in on a static basis, but there is no real science to it. It's just, information that's flowing and collected manually and pretty quickly gets old and outdated, or in this case is incomplete. The flip side of that is connected vehicle technology opens the door to both real-time and historical data on how the roads are being used. Data will be readily available for immediate analysis. If you ever have a chance to go to Las Vegas, it's probably not one of the biggest sites that you ever want to see in Las Vegas, but the FAST Center, I forget what FAST is an acronym for, but it's the Regional Transportation Commission Center where they manage all the traffic. So all the traffic cams get streamed in there. The light timing is all managed from the center. And it's basically walking into a war room. They've got a whole wall full of very large screens that are showing a variety of information. They're getting a lot of data, but it's mostly visual. And it's not something that they're actually being able to do a lot of analysis and comparison to other data. And this allows them to do that sort of thing. The other thing that's interesting that they mentioned is that, it's easy to find trends or consistencies. I shouldn't say it's easy because you guys wouldn't have a job if it was easy, but you get the point that consistent things and trends are much easier to find than the outliers. And they're hoping that increasing the amount of information and the type of information they get will enable them to identify outlying information that they may not have before. Hard stops, higher, slower speeds than posted, and so forth. They're also very keen, and again, the GENIVI pilot is only one of several projects that they've launched. They're really trying to be innovative in rehab projects, putting sensors in pavement, doing a lot of different things, deploying roadside radios, Wi-Fi. They have a whole innovation district downtown Las Vegas, which most people don't get to unless they have to go to court. Then most people go out to the resorts and the Strip and so forth. But the downtown's actually kind of cool, and they've got a lot of technology deployed. They're deploying more. They're hoping to gather additional data sources through that technology deployment. And so the pilot here is just their toe in the water, if you will, with receiving active data and being able to combine that data to find interesting information. In talking with them, and you all who have done data deployments probably are well aware of this, that they all expect to see a lot of discovery when they start putting data together. In fact, I would expect that there's going to be a lot of light bulbs that are going to go on when they start seeing the capabilities of being able to pull data sources that they already have under their roof and combine it with other data sources and this information and see the discoveries that are going to occur. So, and then of course the last thing is that there's a growing need and interest in deploying vehicle to infrastructure technology. DSRC is what they call it in auto speak, which is, by the way, very expensive. And while it does have some really interesting benefits in terms of low latency and the real-time nature of being able to communicate between the vehicle and infrastructure, it remains to be seen whether it's going to be something that has broad enough distribution and installation to be of real use long term. And so this gets them into the whole mode of thinking about communication activities, communication technologies. It's not just about data. What works? Would a broad Wi-Fi deployment be better than a broad DSRC deployment? Or should we just wait for 5G and call it good? And so all those sorts of things are things that they're learning through this pilot. And so there's a tremendous amount of benefit to the city and to the region. GENIVI, on the other hand, is an open alliance, and our benefit is, gee, if we can help the city and region solve some of their challenges, we want to do that, but we are very interested in remote vehicle interaction as an open technology. It's been developed within GENIVI. We've tested it. We've done demonstrators in a number of different contexts. Hortonworks have been involved in some of those demonstrations. We've done demonstrations of vehicles talking to smart homes and smart homes talking to vehicles. Obviously, this is a use case about car to server technology, but we can also do car control technology. So for example, if your smart refrigerator says you're low on milk, it can send a message to you on the way home to say, hey, by the way, you should stop and pick up some milk. So those are the types of connectivity. I know that's probably not the greatest use case, but it's possible with remote vehicle interaction, given the appropriate setup and gateways and so forth. So we're excited about remote vehicle interaction. We're excited about the opportunity to marry car companies with cities. Those of you who may be more in the automotive space know that the last year before last, there was a U.S. Department of Transportation did a Smart City Challenge, and they thought that they would get maybe 13, 14 cities that would sign up, and they got, 72 or something like that. And that showed the interest in cities to deploy technology and to test technology with connected vehicles, autonomous vehicles, and vehicle-to-infrastructure technologies. And so there's certainly a strong desire to see that happen more and more. This is, like I said, a toe in the water for the city of Las Vegas to understand the value of data combinations, and the value of having basically roving sensors throughout their roads and arterials and so forth. So that's the big picture there. Geez, I don't remember this slide, but we'll talk to it. So this project is based a little bit on some proof of concept work that was done with GENIVI and JLR and an RVI proof of concept. I've talked a little bit about that already. And I think that's it. So with that, I think we can go to questions if there are any. Been a long day, hasn't it? Oh, question, yes.
You mentioned waves earlier.
I'm sorry, I think they're going to run a mic over to you so that you can repeat your question. Something about Waze.
Yeah, we got recorded.
Sorry. You mentioned Waze earlier. Have you talked to Google about using that data set to enhance this solution?
Not specifically in the context of this pilot. So the question was, have we talked to Google, have we talked to Waze, have we talked to other organizations that are producing a lot of data and that sort of thing? Not yet. We are talking to some other organizations who are producing through their applications basically large data sets that could become available. One is an organization that specializes in equipping ambulances and emergency vehicles with an app that produces a data stream so that you know where that emergency vehicle is routing, where it is at any given time. That's actually information that we're considering pulling into this pilot and sending, creating another use case that could say, for example, warn the driver if their trajectory is toward an emergency vehicle that's either parked or is routing in a intersecting way to them. So these are the only data sources that we have today, but there is an openness to doing more in the future. Yeah.
Just one other point too. One of the things that was very interesting with the city is the city envisions, look, we're collecting this vehicle information, vehicle location information, right? But the key use case here was actually we're taking that information and they were augmenting it in this case with the city bus information, right, with the city location information. And those are the types of use cases, and, you know, arguably on 3 of those use cases, you could do a lot of this in vehicle, but this is where you couldn't, right, because you were bringing in city bus information around the city. The city also recognizes that this is just the tip of the iceberg. You're going to you could bring in information from insurance companies, for example, that would say where are high crime areas, right, from police report, all those types of things. So this was more of a proof of concept, but their whole thinking is, look, there's going to be more and more data that we need to create this connected world to be able to improve safety within the city.
Thanks, Mike. Yep.
I'm just curious, you mentioned installing a device in one vehicle so far. Why installing a device when everybody carries a smartphone, which actually already records vehicle speed and location information?
Okay, so the question is, why did we not just decide to do an app and use that as the basis? Well, first of all, we're an automotive alliance. And we're an automotive alliance. And so there's this love-hate relationship between apps that ride in the car and apps that are native in the car. Okay, there's a big difference between the two. The BMWs of the world want to own the apps in the car, as opposed to you carrying your apps into the car with your smartphone. So this onboard unit that we're bringing into the car is really just a technology that we had to do because we didn't know exactly, because we're using city fleet vehicles, and they don't have one fleet vehicle type, they have 12 of different model years, some of which have in-vehicle infotainment systems, some that don't. And so what we wanted to do was standardize what was in the car so that we knew that we would always be able to connect to that. And we could have done that through an application or through a mobile app, but we decided to do it through automotive technology instead. So because we're an automotive alliance.
On that note, while fixing 150 cabs in Vegas is nice, with the smartphone app, your reach could be a little bit broader. You could even get some of the people that regularly drive in there from LA to install this in their car or on their smartphone.
Sure.
And then have it activate in a geo-fenced manner.
Absolutely. We could have done that, and as I said before, what we have presented is the initial scope of the pilot. We have at least 2 other organizations that are app-based and producing data streams that we likely will bring into the pilot in the second half of the pilot, so the second half of the year. And so, to your point, yes, we could expand significantly. Right now, this is more about as Mike said, proof of concept, getting the city familiar with data streams and the value of a connected vehicle.
Well, it's a good start. I'm not sure you'll see it in the data yet.
Okay.
Not until you get a little bit more adoption among the entire cab fleet.
Yeah, thank you. Yeah, and by the way, we're not going into cabs. We're going into the employee fleet of the city management and the regional management. Not management in the sense of chief operating officer or anything like that, but the people that are going out and checking permits and looking at restaurants and those sorts of things, they're driving the city fleet vehicles, and that's what we're equipping. Yeah. What's that?
They don't drive on the strip much.
That's not the target. Believe it or not, that is not the target. There's other corridors that are more important to the city and the county than the strip. Believe it or not.
It was always surrounding, so people using the buses, people using,
Yeah.
more of the residents of the city.
Yeah. Yeah. Other questions? Great questions, by the way, at 5:40 in the afternoon. You guys are champs. Guys and ladies, sorry, that's a Chicago term. Everything is you guys in Chicago, right? Yes. Yeah, sorry. Use guys, thank you. Isn't that Boston? I don't know, whatever. Yeah, New York. Any last questions before? I guess there's one more session
There is one more session.
One more session, so you can't go to happy hour yet. So you have to go to that last session because but anyway, thanks a lot. If there's any questions, we'll be on the side.
Thank you.